All right, everyone. This is a review of the first part of Unit 3. This was actually the end of first semester. So this is going back a ways, but a lot of these skills we've used throughout the course, so hopefully some of this should be pretty fresh in your memory. So we did a mixture of things in the beginning of Unit 3. Ratios and proportions were one of those topics. Then you saw that in the context of a word problem. We did basic area of shapes in geometry as well. So going back to the top here, these first couple of questions, basically if it says simplify a ratio, as long as you have the same units, you just reduce the fraction. So this is feet and feet, and I'm looking for a number that goes into both 8 and 36. That number, the greatest one I can think of, the greatest common factor is 4, and that would leave you with the fraction 2/9. Now, if you had divided out 2 because they were both even, and then you wrote 4 over 18, just know that you can still divide out another 2 to get to this most reduced form of 2/9. Okay, so that said, if we move on to number 2, this has different units. This has feet and yards. So before you do any reducing of fractions, you have to have the same units. Now, there's 2 different ways you could go about doing that. In one case, you could try and change 12 feet into yards. And the conversion for that, 3 feet are always in 1 yard. So if there's 12 feet, we're just going to say X yards for now. And you could solve that proportion. Or if you wanted to, you could have changed 45 yards into feet. So another thing you could have done is looked at this and said, same conversion. There's always 3 feet in 1 yard. So if I have 45 yards, how many feet do I have? Now, I set up a proportion in both of these cases. You could have just understood the conversion between these two. Like, for instance, the one we just wrote here. If there's 3 feet for every 1 yard and you have 45 yards, the scale there would just indicate to you should multiply 45 by 3, which is what you actually do in this case. And you get 135 feet. So if that makes sense to you, I would convert the one that's easiest to understand. If your brain went here and you wanted to convert 12 feet to yards, that's fine too. You have a little bit more work ahead of you. You would actually have to divide. And you end up getting 4 yards. So it's really, there's no perfect answer. It's kind of up to you. In this case, feet converted to yards and yards converted to feet without any trouble or decimals or anything. I will say that you probably don't want your numbers to get too much bigger, because if you notice, 4 is a little bit easier to work with. 12 feet becoming 4 yards, 4 over 45 is smaller numbers. Whereas if you end up changing 45 yards into an even bigger number of feet, which is what we did here, then that fraction becomes 12 feet over 135 feet. Now, that's not exactly the easiest thing to convert in your head. You know, finding a greatest common factor between 12 and 135 might be a little challenging. The actual greatest common factor between them is 3. And you would actually just end up getting this right here. This is the reduced fraction, 4 over 45. So this one seemed a little tougher because I showed you 2 different ways to do it. But what I would basically recommend to you is don't make your work harder. In other words, if 45 yards is going to turn into a very large number of feet, you might want to avoid doing that, because now you're dealing with bigger and bigger numbers. It might be easier for you to have done this one. And actually, you would have been done right away. There is no more reducing. So whichever you prefer, the final answer is 4 over 45. But I think you'll see in number 3, it's a little more clear what your step should be. So here, this is a more common conversion. We know there are 12 inches in 1 foot. You probably would not want to work with 70 inches, because if you know your times tables, 12 does not go into 70 evenly. So it would probably be in your best interest to just change 5 feet into inches. So that said, if I have 5 feet, how many inches do I have? Again, you probably understand that you're just going to multiply by 5, and that's 60 inches. So this becomes 60 inches over 70 inches, and a 10 can be divided out of both of these, leaving you with 6/7. So again, usually there's a clear choice. I would choose to change 5 feet in this case. Number 2, there wasn't a clear option. That was a little bit more tricky. And number 1, they were the same unit. You just had to reduce the fractions. Now, something you've seen us do for the past couple examples is cross multiply. So a proportion is when you have a ratio set equal to another ratio, and you would cross multiply. Now, in the case of number 4 here, the question's pretty straightforward. 28 times x, 84 times 3. That's technically what we did to make 252 here. That would then be divided, and this one's done relatively fast. The answer is 9. Number 5, be careful. If you're going to cross multiply and you have an expression, I'd put parentheses around it, because when you do 4 times that entire quantity up there, you want to make sure you distribute it to every term inside the parentheses. So when we do that, we're going to have 8x, and we're going to have minus 16 equals 72. And then once you add that, I think you'll see what the answer is going to be. If 8x equals 88, x must be 11. Okay, so cross-multiplying proportions. Another way you could do that type of work is in a word problem context. Now, sometimes you don't have to set up the whole proportion. Sometimes you can use what's called a scale factor. So for instance, this question says a desk measures 4.5 feet in width. How many inches is that? Well, first of all, you could do a proportion. If there are 12 inches in 1 foot, I have 4.5 feet. How many inches is that? That is one way you could do it. Now, the other thing you could do here, if you want to think of this as scale factor, is, let me just move this out of the way. There's nothing wrong with that. The scale in this problem is for every 1 foot, there are 12 inches. So if you have 4.5 feet, the scale is you should always add 12 inches for every 1 foot. You could just kind of mentally think this is 4.5 times 12, which is the work you would have done in your cross multiplying anyways. So if that's your choice, or if cross multiplying is still what you prefer, that's fine. But that's a way of showing a little bit less work if you do it that way. Now, number 7, again, up to you. If you want to do a full-on conversion, you can. If you want to do a proportion, rather. But this is asking which distance is longer. And frankly, I think it's easier to convert 50 yards, because if I know there are always 3 feet in a single 1 yard, and I have 50 yards, well, I'm just going to multiply that by 3. And that's going to quickly tell me how many feet that is. So if it says which one's larger, boom, 50 yards is. All right, now number 8, they actually mention the word scale. So again, you could do a proportion here. If you're comfortable with a proportion, you could say, all right, I have the model of the Eiffel Tower and I have the real thing. Let's compare the height to the width and the height to the width. So if that's the case, the model height, I don't know. So I'm going to call that x. The model's width, it says, is 12 inches. Okay, so those are both inches. That's for the model. In real life, how tall is the Eiffel Tower? It says it is 984 feet tall and 328 feet wide. And you could then cross multiply. So if that's what you prefer, you could compare these two here, and then you could cross multiply. On the other hand, if you wanted to understand this in a different way, you could have changed, this 12 inches to a foot, multiplied or divided by 984. That's a little bit tougher in this case. This has a couple things going on. I probably wouldn't do the scale factor method. I would probably do this as a proportion. But we'll talk about scale with number 9. So that said, this would be 328x equals, now 984 times 12 is going to be a big number. That's going to be 11,808. And if you divide by 328, you're going to end up with 36. And again, since that was the model, that would be in inches. All right. Now, let's talk scale here. Number 9, and you may have seen this before on a map. There's a scale or a conversion. Every 1 inch represents 50 miles. And you measure from Chicago to Las Vegas and see that it's 35 inches. I would just multiply 35 and 50. Because if every 1 inch is 50 miles and there's 35 of them, multiplying would quickly give you the answer. And again, you could have set up a proportion as well, but I think that's a little faster. Okay, so what remains are basic area. Now, these are what we'd call compound figures, where there's 2 rectangles here, but you're going to want to break it down into their component pieces to find the overall area. And what's tricky is this. You can very quickly see this is 2 times 7. That rectangle is 14 inches squared. But this one down here, the one I'm kind of just scribbling on, it isn't 5 times 4. Remember, if this is 2, this length is 2. And if the entire length is 5, that means this particular length here is 3. So 3 times 4 would give you 12 inches squared for that smaller rectangle. And then the total would be the sum of those two, which is 26 square inches. So if you ever have a compound shape, just be careful. Now, number 11 is a trapezoid. And if you knew the trapezoid formula, you could just do it. But when all else fails, this is a compound shape as well. You basically have 2 triangles that are the same because they have the same dimensions. And they both have a height of 11 feet. But what's tricky is what's their base. Now, you're shown that this is 28 feet. And this one here that I'm tracing in red is 18. So I know this is 18 here as well. So if I were to do 28 take away 18, that leaves me with 10 feet of leftover space. But I'm going to divide that by 2 because there are 2 blue bases to these triangles, which means they're each 5 feet. So if I rewrite that, this is 5. This middle length is 18. And then this is 5. And that's where we get that 28 from. So essentially what you're doing here is you're finding the area of a triangle, and then you're going to multiply that by 2 because there's 2 of them, and add that to the area of the rectangle. So the triangle, the formula for a triangle is 1/2 times the base, which is 5, times the height, which is 11. But since there's 2 of them, we're going to write times 2. And the rectangle in the center is an 18 by 11. So that area of a rectangle is just length times width, or base times height. And we're going to add these 2 up. So the triangle, that becomes the 2 triangles rather becomes 55. 18 times 11, that's 198. And that is a total area of 253 square feet. Okay. So all that's left is circular shapes. And for the area of a circle, if you've forgotten that formula, that is pi r squared, where r stands for a radius. And in a circle, the radius is the distance from the center out. But if you add a radius and a radius, that makes what's called the diameter. So a radius is half the diameter. So if you're told you have a diameter of 14, that means the radius, half of that length, has to be 7. So they're basically saying, what's the area of a circle with a radius of 7? Oop, I don't know what I wrote there. So this is pi times 7 squared. Now you could write this as 49 pi square centimeters, where you keep pi in the answer. But that's something that, again, we haven't talked about in a while. And if it was a real life problem, I doubt they'd want you to keep your answer in terms of pi. So you'd probably multiply 49 in pi And again, if you forgot, pi is approximately 3.14. So if you didn't have a calculator that can multiply that for you, you could substitute 3.14. But if you do, it's about 153.94 square centimeters. All right, now last but not least, we're talking pizza. So our pizza question here, pizza is priced by square footage or area or square inches. So everybody, it says here a jumbo pizza that 18 inches, that means diameter of 18. All right, so they always talk about the diameter when you see pizza prices. And then it tells you how much they're charging. It says first to find the number of square inches. Now, per dollar. So it's not coming right out and saying it, but you basically need to find the area. You are looking to find the area of a circle divided by its price. All right, so for jumbo, that would be pi r squared. Now remember, this is a diameter of 18, so the radius is 9 for jumbo. So that's like saying pi times 9 squared divided by 18.99, whereas the extra large, XL, is going to be pi times, now that's a radius of 8, so this is going to be pi times 8 squared divided by 16.99. So the price per square foot of these two pizzas, so the jumbo one is going to come out to 13.4 square inches for every $1 spent, whereas extra large comes out to 11.83 square inches for every dollar spent. So which one gives you more? Technically the jumbo. It costs more, but you get more for your money. All right, so that is a review of Unit 3. A lot of old school geometry and area, ratios and proportions and scale factors. If you have any questions, let me know.